This video will summarize the Math 1 lesson titled Elvira's Equations. This is a Solidify Understanding task. The purpose of this lesson is for students to solve formulas for a variable and use units to help solve and understand problems. In this task, Elvira, the cafeteria manager, likes to keep track of things she can count or measure in the cafeteria. She hopes this will help her improve the efficiency of the cafeteria. To remind herself to keep track of important quantities, she's made a table of variables and descriptions of things she wants to record. Here is a table of things she has decided to keep track of. This is where she's defining her variables. These are the letters, the variables that she's using. This is what they mean. And then units are also really helpful in making sure that you know what you're finding and that your answer makes sense. So the units, or what is counted or measured, are listed right here. Whenever you see this division bar right here, this /, that's division, and I'm going to say the word per, so this is dollars per student. Elvira has written the following equation to describe the cafeteria relationship that seems meaningful to her. She has introduced a new variable a to describe this relationship. So a equals s plus w plus p divided by c. The first question is asking, what does A represent in terms of the school and the cafeteria? And we need to record it in the table as it's recorded here. So let's make sure we understand why A represents the average number of students buying lunch in the class. In the numerator, we have S plus W plus P. So S, W, and P are listed right here. When you add these together, you're getting the number of students buying lunch on the salad line, plus the sandwich line, plus the pizza line. So this sum is representing the total number of students buying lunch, because those are the three lines that are in Elvira's cafeteria. All right, so if the numerator is the total number of students buying lunch that's in the day in the cafeteria for the whole school, we can divide that by C, or the number of classes. And that's how I got my unit. So these have the unit of students, so we were adding students. So that's this unit students in the numerator. And then the denominator was in classes, so it came to the denominator. So students per class. So that's an average whenever you take the total and then you divide by a certain amount. In this case, the classes, we're finding the average number of students buying lunch in a class. Now, the question is asking us to use what we know about manipulating equations to solve this equation for S. Your solution will be in the form S equals an expression written in terms of the variable A, C, W, and P. So our answer is going to have these variables S, A, C, W, and P. This is called a literal equation, when we have multiple variables and we need to rearrange them or manipulate them using our algebraic properties. First thing I'm going to do here to manipulate this question to isolate S or get S by itself, I'm just going to rewrite the equation to give myself a little bit of room. Then I need to think about what I need to do first. When I was originally looking at this problem, I understood that it was S plus W plus P. That happened first to get the total, and then it was divided by the number of classes. So I need to do the opposite. So here I'm going to use the multiplication property of equality, which means I'm going to multiply C on both sides of the equation. I'm using multiplication because that's the opposite of division, and it's called a property of equality because I can multiply by the same value on both sides of an equation, and it does not change the balance of the equation. So over here on the left, when I multiply C times A, I have CA or AC. That order doesn't matter, whichever way I write it. And then I'm going to bring down what's left on the right, so I have S plus W plus P. My next step then will be to subtract the W and the P. Since they're being added, I want to do the opposite operations. So this is a subtraction property of equality. You could do this one step at a time, subtract the W and then go back and subtract the P, but I'm just going to do it all at one time. Over here on the left, since I'm subtracting W and P from AC, it's really important that I write AC first when I write my next line of my equation. Then I'll bring down the equal sign and the S. So now S is by itself, so I've succeeded. Even though it says S equals, it can still be equals S. When I rewrite it so that it's S equals, I still have to make sure that I list AC first. So AC minus W minus P. And there we have it. We have all of these variables with the expression that is equal to S. Number 3 asks if our expression for S, so if this equation, does it make sense? Remember, an expression does not have an equal sign, and an equation does. So does this whole equation make sense, having this expression on this right side? A times C. A was the average number of students buying lunch in a class. And if we multiply that by the number of classes in the school, what we're getting with AC is the total number of students buying lunch in the class. So AC, when you take the average number of students buying lunch in a class, multiply that by the number of classes, then you're getting the total number of students buying lunch for the whole school. And if we subtract out this W and this P, so you're subtracting out the number of students buying a sandwich and the number of students buying a pizza, what you're left with is the number of students buying a lunch in the salad line. So yeah, that makes sense. If you take the total number of students buying lunch and you subtract out the other 2 lines worth of students, you subtract out the students who are not buying salads, then you're left with the students that are buying salads. Elvira is having a meeting with the staff members who work in the lunchroom. She's created a couple of new equations for the food servers. What does D sub F represent in terms of the school and the cafeteria? Record this information in the table above. So D sub F is a variable, and the F is a subscript, which is why I'm saying D sub F. So let's make sure we understand what D sub F represents. In the numerator here, we're multiplying by T and P sub L. So T is the total number of students buying lunch, and P sub L is the price per lunch. So these are the 2 variables we're dealing with in the numerator. So if you take the total number of students that are buying lunch, and you multiply that by the amount of money each student is paying, the price per lunch, what you're getting is the total amount of money that the cafeteria is collecting. So this is going to be the total money collected, right? Then we can divide this by F, and F represents the number of servers. So when we're trying to understand this, we have the total money divided by the number of servers. So that is dollars per server, which is where this unit came from, dollars per server. Now we need to solve the equation for P sub L and describe why the solution makes sense in terms of the other variables. I'm going to start by just rewriting this equation. To solve this equation for P sub L, we need to start with what's furthest away from this variable. When I say furthest away, P sub L is first being multiplied by T, and then this product is being divided by F. Since the numerator is being divided by F, I need to multiply both sides of my equation. So this is the multiplication property of equality. Multiply both sides of my equation by F. This gives me F, I'm going to use a dot for multiplication here, times D sub F equals T times P sub L. All right, my next step in getting P sub L by itself is to divide both sides of the equation by T, doing the division property of equality. So I have F times D sub F divided by T. So when I want the equation for P sub L, I have P sub L equals F times D sub F divided by T. So does this make sense in terms of the other variables? Let's look at these other variables again. F was the number of food servers in the cafeteria, and D sub F was the average amount of money collected per server. So now my numerator is telling me, if you take the number of food servers and multiply by the average amount each one of them is collecting, then here you have the total amount of money collected. And then if you take that product and you divide by T, which is the total number of students, you have P sub L. You have the amount of money, so the dollars per student. So in summary, in this lesson, we solved literal equations for a specified variable. and we made sure to define our variables so that we could understand what they meant and understand why solving the equation made sense. Also, we looked at some properties of equality. We looked at the addition, subtraction, multiplication, and division properties of equality. Properties of equality when you perform an operation that does not change the balance of the equation. In other words, you can add the same value on each side of an equation and it won't unbalance the equation. The same with subtracting, multiplication, and division. All right, thank you for watching.